Thanks everyone. Very short talk then. I want to talk to you about being green in technology. I'm want to talk about a project that I've been working on and off for around the last 6 months, maybe a little bit longer, around carbon aware scheduling. So a little bit of obligatory information about myself and where I'm doing this. So I'm a developer, I'm a technical architect, but I think more than both those things, I'm a software deliverer. I kind of like most aspects of software delivery and not particularly keen on sort of role and job titles. So whether that's sort of development, testing or analysis or whatever, I enjoy the full suite of things really. But having said that, my background is very much in the Java and .NET space, backend software. I've enjoyed a number of projects in low latency software, and sort of sectors-wise, finance, manufacturing, and healthcare is where I've spent most of my time. I'm currently engineering lead for BJSS's Sheffield and Lincoln offices. That, amongst other things, I sort of support the architects and the technical quality on the projects we prime. I support the people, career progression, stuff like that, but I also I'm lucky enough to still be hands-on and get my hands dirty, which I very much value. BJSS themselves, we are a global IT and business consultancy. We are headquartered in Leeds, but now have 100 people based just around the corner from here. We deliver quality software for and with our clients. And we're also, incidentally, on the topic of it today, we're also restoring 125 acres of land in the Yorkshire area, from planting and all sorts of activities going on. And interestingly, from the sort of the IoT side, we're looking to leverage tech to help us do some of that as well. But that's not today. What I want to talk to you about today isn't this side. There's two sides that we generally distinguish when we're talking about green in and around software, and that's green tech or green with technology. So doing something which is going to help out our environment. That's from the outset. We're looking to deploy technology in a way that'll improve the situation. Alternatively, we can look at what we're doing already in technology and actually try to improve the way we're doing it and lessen the burden, or even maybe have a positive impact whilst doing something entirely different. And that's where I've really focused myself probably around the last year now, and as I said, the last 6 months or so with this specific project. So being green in technology is where I'm talking about sort of the full software delivery lifecycle. Can we improve the way we're actually delivering the software? Can we not use as much energy to deliver the stuff whether that's our pipelines to get the product live, or whether it's our developer machines. All of those things are using electricity and therefore emitting carbon and other greenhouse gases. Hardware efficiency, software efficiency, and right through from requirements. Another talk I do is more around software delivery lifecycle. And one of the most important things we can do is actually not deliver the software. Right? That's probably the best way to say it, and sometimes just question the worth in what's been delivered, or maybe not the whole thing, but part of it, or just kind of scale back the requirements is really important too. And it is important because ICT is having a big impact. Okay. Estimates that this is changing by around 9% a year, costing now more to the environment than the aviation industry. Okay, so we can have a big impact as people in this industry. So it is important that we not only look at these carbon for capturing technologies and so forth, but also the other stuff that we're doing. So, as I say, I'm not going to focus on the bigger part of how to deliver software more efficiently and so forth. But I want to focus today on, without changing the software, what simple thing could we do to have a better effect? And one thing we can do is look at not running our software when the grid, so the electricity we're using to run that software, is at its worst, at its most intense for carbon. And when I say carbon, actually I should caveat that we're not just talking about carbon, we're not just talking about CO2, we're talking about a number of greenhouse gases, which include CO2, but we generally measure things in what the equivalent is in CO2, okay, so CO2 equivalents. Now, this sort of one on the your right-hand side is showing a example mix of a grid at a point in time. Looking for the timer, it's gone off. That's okay. So this example here is showing that at this point in time, renewables are making up a small amount followed by nuclear, and then the various gas fuels, and then coal. The impression has been they are more carbon intense the further the right of that graph that we're looking. Now, there's two types of intensity we can take from this. The first one is the average intensity of the grid at that point in time. So simple, we'll take a mean average of those things and we'll work out how bad the electricity mix is, or how good the electricity mix is at that point in time. But actually what's really important when we're looking at workloads and we're looking at to do or not to do something isn't really the average intensity of the grid. It's how much it would cost at that time if we turned our workload on. Okay, so it's actually the marginal intensity of the grid. It's what the changes by adding our workload. Do they have to just allow another turbine to feed electricity to the grid, or are they going to put a little bit more coal on the fire for us? So what we actually look at is kind of the worst, the thing that we're adding to right now. And that's really important when we look at time and shifting our workload. 3 minutes in. Okay, so not everything, of course, can be region shifted or time shifted. By region shifting, then, I mean we don't have to necessarily do everything in London, UK, or in Dublin, or wherever we've chose our if we're using a hyperscaler, with maybe we've got a data center, we can sometimes choose to do it somewhere else. Okay, and so that's region shifting, saying, well, what's the most efficient region right now? But time-wise, we can move a lot of things time-wise as well. So the first one, sort of where I started when we were thinking about this, was really around batch jobs. A lot of the clients we work with have lots and lots of batch jobs. If you think about, I don't know, finance and account opening, a lot of the stuff it looks really slick on the websites, right? And you do it all. There's some big process in the background still that we don't quite see, but it runs, at 9 o'clock at night or whatever it is, and it's doing a big batch of jobs. And that's still the case today. And I actually think there's an argument, again, different talk, but there's an argument for doing more of that again, and maybe moving away from sort of inline type processing to help with this type of thing. But yeah, batch jobs, most of the time you don't have to do them straight away. You've waited all day to do them, maybe wait a couple more hours when the electricity is a little bit better to use. So that's one option. Another one is reporting. Same thing, really. It's just you've got to get some reports ready for a certain time. They've got to be sent out at a certain time. Well, do you have to do them at exactly a certain time? Probably not. You've probably got some leeway at least. Machine learning, this is a really, really big one. Machine learning, as I'm sure we know and has been in the media quite a bit lately, is pretty intense for electricity usage. I saw a stat I don't remember, but it's worth looking at around the intensity. That's going the opposite way, so I thought it was going, I've got less time than I thought I had. It's very, very intense machine learning as well. I'm going to pass these up, except for smart devices, where I'll say there's also an option here, even in household appliances. We time a washing machine. Is that the best thing to do, or should we just say, hey, I need it to have finished by 9 o'clock tomorrow? And the best time that could be useful too. So the need for a reliable carbon-aware scheduler. Now this is key. The word reliable for me. I'm going to have to speak quickly now. The word reliable, because there are already APIs available where we can get data on the intensity of a grid at a point in time, and it can say there's even an API available from the Grid Software Foundation. If you're not aware of the Grid Software Foundation, definitely look them up. There's an API available, Carbon SDK, which will say, hey, here's my workload. When shall I run it? Okay, that's really, really good. But what we need at BJSS really is slightly more than that. We don't want to have to ask something and then decide, right, well, now I've still got to be responsible for the scheduling of that thing. And hey, shall I ask again? Because something might have changed since I did it yesterday. So we want something that's reliable, we want something that's fault tolerant, we want something that if it goes down and it comes up after it should have done it, it's going to say, I've made a mistake, I need to run it now and still within the window, or I need to at least log an alert and all these sort of things. So we needed to build something that was sort of an enterprise level service, which we could, if necessary, build out really quickly, or we could cluster and make something that's got a very high level of fault tolerance. I'm going to have to pass these up. The slides will be available. So you'll be able to use this by saying, hey, here's my scheduling requirements. I want it done every day or every month or every week or whatever. Could do 2 more slides. Okay. And I want it at 6 o'clock or whenever you want it done, and it will say, fine, I've made that. I will now tell you when the workload needs to be done. And how will it tell you? Well, the thing we've built, and this is the thing we've built, it's a very minimal architecture. There's really not much to it. There's 2 points of extension. It is extensible in terms of which service it can use to get the intensity data. We've currently plugged it into the National Grid API, but we've left it open to plug in others. What time is sort of an international one, which is probably a good choice. The other point of extensibility is how it runs your workloads. Okay, so we've tried to make this very general. There's other really good things out there. There's a Kubernetes scheduler that's available as well, which is worth looking at. But we wanted this to work for many projects, so we wanted to be able to plug into an AWS Lambda. Currently we've got it on a webhook. Okay, so it calls a URL that you plug into your schedule, but you could do lots of things there, including plugging it into MQTT server for instance. What's next with this? We need to get to an MVP. We've got this kind of hypothetical, it's really good, we think. But we need to get to an MVP, and we're looking at working with a client to do that. We need to improve reporting. It's all very well saying it seems to have saved us, but we've also built in the real stats, so it looks at what it would have been at the time, at the default time as well, so we can get some stats back. We want to use marginal intensity. The National Grid uses average intensity, and we're going to open source this as well. And just for one stat, we've done some work with a retail trust recently, where we do reporting and a refresh of Databricks every day. We've not used this to do for software. We've used something that looks simpler. We didn't need the reliability, but we've reduced those workloads by 30 to 50% in terms of their carbon. Thank you very much.